Yep, comes on everyone. Let's start off. So this was the last thing that we did. No slipping condition. Great. Let's start with the problem. We have a we have a plank here. We have a spear. We have a spear. There. So we have hexagon homework ना. क्या करना था हेक्सागन के लिए? I said is the easiest one. See, if you take a hexagon, you can divide this into 6 parts. So basically, you can write this thing. You can take one triangle about this point A, and then you can finish it off, right? So I of the hexagon will be 6 times of this. And how do we get this? IA. Don't we already know about the centroid? We already calculated about the centroid, isn't it? How much is that? That is root 3 a by 2. That is a by root 3 ka distance. So IA would be IO plus MA by root 3. And this is MA square by 12 plus MA square by 3. That is 5 MA square by 12. Into 6 times. That would be 5 by 2 MA square. Clear? This is about the perpendicular axis. IZ. IX and IY na. IY, how will you do? Now see, for IX and IY, right, the idea is this. I'll give you an idea. You try this again. Let's see whether you get the same thing. Instead of, you know, adding, we can do something like this. Can I find the... Do I know about this? IX? If I take two big triangles of side 2A, do I know how to find the mode to finish of this? This minus, if I take two small triangles here, so basically that will be these triangles. Again, about the same axis here, using parallaxis theorem. Won't I get the hexagon? About this axis. You getting the idea? What will be this moment of inertia? This will be mh square by 6 now. Remember I about the base. And for this also I can calculate. This will be more lengthy actually. But this way you can figure out for Ix. Same thing I can do for Iy also. For Iy, So here, this will be the height h, and this will be the height h. Minus, again, if I can subtract these two triangles about this axis, again, this is the h here. That won't be h, it will be h by 2. This would give you about the hexagon. So basically, hexagon, right? You have to take two big triangles and then subtract from there. This would give you this. Or could I have done like this? Could I have taken a triangle and a rectangle like this? That also would have worked, right? Instead of subtracting, I could have taken one rectangle like this plus axis and one triangle like this, and I could have used parallaxis theorem. I think that is also good. That also would work. So I could have taken this like this also. One rectangle plus one triangle plus one triangle. That also would have given the hexagon for this. Clear? Now the problem here, problem here is mass of this hexagon is m. So if you make an extra two triangles here, mass won't be m anymore. How much will that be? If I make this total 6 triangles, no? So if I keep two more here, that will become 8 triangles. So that will become 4m by 3. Make sense? Out of all that, IZ is the easiest one. Remaining, you have to figure it out there. So this guy ka mass will be 4m by 3, whereas this guy ka mass will be m by 6 and m by 6. Anusha did the same. You did something else. Clear with this, everyone? Great. Okay, the parallax one. Look at this thing. So we have two cylinders which are rolling on the floor, omega and omega. The upper cylinders are going with 2 omega and 2 omega backward. Let's say this is VP2, this is VP1, which I don't know. This also I don't know. There's no slipping at any surface. There's no slipping between the cylinder and the ground, cylinder and the plank, cylinder and the plank, cylinder and the plank. So total there are 4 points. There's no slipping at any surface. And the cylinders are also going with, let's say, V1 and V2. This also I don't know. Find all of them. Find the velocity of the cylinders in the plank. I just know omega only. The lower cylinders are rotating with omega clockwise, and the upper cylinders are rotating 2 omega anti-clockwise. They're translating, but I don't know the velocities. Find velocity of the cylinders and the planks. Let's get this. So we have two cylinders. On top of it, you kept a plank. On top again, two cylinders and again a plank. How do we proceed? First, get the V1. Start from the lowest cylinder. Take radius is same. R is the radius of all the cylinders. We could have changed the radius also. That would have been fun, but okay. First, let's assume R is same and do it. Udian, can you keep your cam on? VP1 is to R omega. Right, Aryan. Get them all, get them all. Right, Arjun. That part is right. Get the remaining three.
Let's mention the velocity is always of the center of mass, right?
Yeah, when this is velocity to the cylinder, that's what it means.
Okay.
R omega, 2R omega, 4R omega. Hey, Aditya. Check karna properly. God, that omega rotations are reversed. Did you observe? The upper cylinders are rotating in the reverse. ऐसा directly add नहीं कर सकते. That first two are right. Adrit, that is wrong, right? Let me help you with the lower cylinder. See, we are talking about the lower cylinder. Generally, when you get this kind of questions, right, always start from the cylinder. Let's say this guy is going with V1 and this guy is omega. So this bottommost point ka velocity will be V1 minus R omega. Upper point ka velocity will be V1 plus R omega. Now this is in contact with the ground. And this is in contact with the upper plank, which is VP1. So this point ka velocity V ground is equal to 0. Isn't that the no slipping condition? And this is VP1. So V1 minus R omega is equal to V ground, which is 0. Therefore, V1 is equal to R omega. So V1 aa gaya. Here, VP1 should be equal to velocity 1 plus R omega, and V1 is R omega. Velocity of Planck 1 is 2 R omega. So this is how you always take, take the points where it is in contact and finish it off. Now, if you take the upper cylinder, this also, right? I'll assume V2 is going this way and 2 omega is this way. You can choose any direction as V2. So from again, no slipping this thing, velocity profile, this guy will be V2 minus 2R omega. And this guy will be V2 plus 2R omega. And now you're saying this guy is in contact with the lower plank, VP1. And this guy is in contact with the upper plank, which is VP2. I have to include minus signs because I've taken opposite directions here. So this guy would be VP2 will be minus of V2 plus 2R omega. And this guy, VP1 will be minus of V2 minus 2R omega. But I already know VP1 is 2R omega is minus V2 plus 2R omega. Means V2 is 0. The upper cylinder is not translating only. It is at the same place and rotating. So if V2 is 0, then we end up with VP2 is equal to minus 2R omega. Means the Planck is not going to the right, Planck is actually going to the left. Check it out. So the upper cylinders are not translating. They're just rotating at the same place. And upper Planck is going backward and the middle Planck is going forward. Is this part clear now? Why I'm taking a minus sign here? Please check it out. This is how we can find velocities.
So like after a point, the cylinders on the top will roll out, right? Like bubble.
We will not consider those cases. The
Uh,
plank is long enough.
yeah, no, I was just thinking of questions that can come.
That thing, it would be more messy, right? बहुत issues हो जाएगा. Because once the cylinder doesn't fall off, right? If the plank goes off like this, N will change, F will change, a lot of things will change.
Okay.
Clear with this, everyone? Have a look at this. Vartika, Rehan, clear with this? Utsa, got this? Maulika, clear na? Abhinav, clear? Next one, going ahead. Let's see one more. We have a cylinder with multiple radiuses. Like this. So this is the kind of pulley. You can have a string wrapped around different cylinders there. This upper one is placed to block A. This lower one is placed to block B. This is radius R. This is radius 2R. Velocity of A is V. That is given. Velocity of B, I don't know. There's no slipping anywhere. Find velocity of B. Find V and omega of the cylinder. I hope you're getting the diagram how it is. Basically, this string is wrapped around the cylinder. This string is wrapped around this cylinder. This pulley is kind of like this. The string is wrapped around two different radiuses. Two different strings. Now, if this cylinder rolls without slipping at any surface, find the velocity of B, velocity of the cylinder, and omega of the cylinder.
So can you repeat the question again?
Which part you didn't get?
That under one.
This one. It is like this right here. We have one radius here and one radius here. This is connected here and this is connected to another block.
Okay.
So two different radiuses are. It is like one Aryan, that is, the whole thing is one system, right? Dekho na, this is the diagram here. Like, they rotate with same omega, isn't it? Fair enough. Anyone still confused, please ask. I know the diagram can be a little confusing. It's like you wrapped around two things.
Is horizontal or placed vertically?
What? Ground is their god. What are you talking? This is a side view, Ray. Still confused? There is a gravity here, God, or else why will A and B move? They'll be at rest, isn't it? V is V by 2. Okay. Not exactly.
Is it constant? Is
Near.
it going with constant velocity?
Come again?
VA is constant.
No, at this instant, A ka velocity is V. Bus. So give me answer in terms of V. Na? V is changing, remaining also will change. That's okay. No, Rakshika, that's not the answer. I don't think that is the answer. Anyone else confused with the question? Please ask. This is a side view. Basically, there is a gravity here. Because of the weight, A is coming down and that is pulling the cylinder. So this cylinder is actually having V and omega. Abhinav, diagram is clear, na?
Yes, sir, I understood.
Understood, no?
So
Yeah.
this is like similar to that doctor's tape dispenser, right? That
Doctor staped. हाँ, spool ऐसा ही है. Thread dispenser, but there are two different
spools
radiuses.
kept on top of it.
Kind of, yeah. Anyone? Answers? I thought someone will answer by now. Why are you guys struggling with this? I'll tell you one thing. See, whenever you get questions of this sort, right, always start with the cylinder. Always start with this thing. Assume this is going with V and omega. Now there are 3 points of contact. This point will be V minus 2R omega. This point will be V plus R omega. Radius is 2R, huh? Don't forget. The upper one will be V plus 2R omega. This guy is connected to block A. This guy is connected to block B. And this guy is in contact with the ground. So no slipping condition. V minus 2R omega is equal to V ground, which is 0. So V is equal to 2R omega. And this one here, V plus 2R omega is equal to VA. Let's write this as VA. And V is equal to 2R omega. So that would be 2V is equal to VA. So I'll also show the center is VA by 2. And omega also will get it from here anyway. So 2R omega is VA by 2. So omega is VA by 4R. And this thing, if I assume B is going up, velocity of B is equal to V plus R omega, which is V is VA by 2 and R omega is VA by 4. So that is 3 VA by 4. Check. So all answers should be in terms of A ka velocity. So the center is going with VA by 2, omega is VA by 4R, and B is going with 3 VA by 4. So there are 3 points of contact, right? So this is one, second, third. You get 3 equations there. 3 no slipping conditions. Any doubts on this? Anyone not convinced with this? Please ask me. Not tough, but it's a good one. You need to know like the velocity profile and everything. So this is how normally no slipping conditions will come.
This is independent of the mass, like however heavy the block A or block B is.
Meaning it's like just like constraints, right?
Okay.
Just like constant, meaning one velocity is given. This is how the velocities will be related. If you have different masses, you'll get different values of A. It's like constraints. Na? See, if I take 2 block here, A and B, I am not asking what is the value. I am saying agar ye B hai, to ye B niche hai.
Okay.
Bas, A and B ka mass can be anything it wants, so we don't care. But the bottom part is always minus. In this case, you have to be careful, Aryan, how you took omega. Suppose if I had taken omega this way, the bottom would have been V plus 2R omega. It all depends on your choice. You can choose omega. If it is not given, you can choose anything. I just took it like that. So if you take reverse, to tujhe niche V plus 2R omega aega. That is fine. The science will take care of it. All clear with this? So there, these are the 3 parts which I said, like, one is calculation of torque, moment of inertia, no slipping condition. Now we are done with the basic part. Now all the basics are ready. Now it is like, in cooking, what is the most important part? What? Cutting vegetables. That is the most tiring and the most time consuming part. Cooking is actually, it takes less time. Let's see how to solve this thing. So the steps. Steps to solve. First one, choose your system. The first step is standard actually. Choose your system and draw an FPD. Second thing, assign linear and angular accelerations. Let's say there are 3 blocks, give them A1, A2, A3. If there are 2 cylinders, give them alpha 1, alpha 2. And find relation between them using constraints, which you studied in laws of motion, string constraints, rigid body constraints, and no slipping condition. No slipping condition we did today. Third, apply F is equal to ma along 2 perpendicular directions. So choose your x and y axis, resolve the forces and accelerations, and apply F is equal to ma. This is also standard. Fourth, apply torque is equal to I alpha. You can take torque about any point, but preferably we choose, preferably about hinge. Basically, you want a point in the inertial frame or center of mass, or basically any point in inertial frame. You don't want to include pseudo forces. Any point in inertial frame. So as long as you can be sure there are no pseudo forces, you can take it. But if you want to take a non-inertial frame, there is no problem. You have to include pseudo force. So the formula actually becomes like this: torque due to external plus torque due to pseudo force will be I alpha. So you have to include this. Now, about all this thing, center of mass is special. Suppose if center of mass is accelerating, right? And if you stand on the center of mass, where will you apply pseudo force? I'll give you an example. See, let's say there is a truck, and let's say there is a cylinder, solid cylinder, high touch, and truck is accelerating with it. Now, if I tell you draw the pseudo force on the cylinder when observer is standing here, what is the pseudo force? Mass into negative of acceleration of the body. Where will you apply this? At center of mass, isn't it? You apply the pseudo force from center of mass. That means even if center of mass accelerates, if you take about center of mass, the pseudo force will pass through center of mass. Therefore, the torque won't matter. So about center of mass, torque about pseudo force is 0. So center of mass is one special point. Even if it is accelerating, which is a non-inertial frame, the formula still works properly because the pseudo force will pass through center of mass. So you can always talk about center of mass, it always works. But any other point, you have to check. Are you getting this point, what I'm trying to say? If you go and stand on any point which is accelerating, you have to include pseudo force. That is fair enough. But among all those points, this center of mass is a special point. Even if it is accelerating, when you go and stand on center of mass, the pseudo force will act on the center of mass, so torque will be 0. So this term will be always 0 for center of mass. So center of mass will give you as if it's like an inertial frame. We'll see later on. I'll show you that. So solve the equations. That's it. This is your standard format. Let me give you any type of question. These are the steps that you have to follow. There might be variations, but this is the general flow. Please have a look at these points. Clear? Can I go ahead? Vidyut? Clear, na? Yasha? Clear so far? Ali? Neil? Palaksh? Perfect. Let's go ahead. We have a rod here. We have a string connected here. Mass M, length L, rod, and you connected a block here of same mass M. This is a string. And this is connected at a distance x from the hinge. Someone took a scissor and they cut it here. First question. Find alpha of the rod when the string is just cut. Second one,
You go
plot.
previous page for a bit. Clear? Yes.
Plot alpha versus x graph. That would be fun. Second is a good one. If I keep changing the position of this block x, how will the angular acceleration change? Again, this is all just after cut. And string is cut. Just after cutting. Let's see whether you'll find a trap. X is L by 2. Why x is L by 2? Who told you? Arjun. If it is L by 2, I will write L by 2. Na? Why will I write x? Let's see. First, let's see whether we'll get the FBD right. Row of the steps. Step 1, draw the FBD. Step 2, apply, force assign accelerations and alpha. Find the relation between them. Step 3, write forces horizontal, vertical, torque, solve. Try for 2 minutes, then I'll show you. Malika, adjust your camera a bit, right? Can't see you. Rehan, you also adjust a bit. I'll show you the FBDC. Let's see how many of you got the FBD right. Hinge reaction, whenever you see a hinge, Nx, Ny, rod ka own weight mg, this is tension T. If you have written mg here, it's a blunder. That is a first mistake generally people do. If you have not done, great. If you have done, that is a mistake. Who told you T is equal to mg? You are assuming block is at rest. Isn't it? T will be mg if the block is at rest now. So FBD will be tension and mg. You can't take T is equal to mg. That is T is equal to mg if the system is at rest. If the rod is moving down, how will T be equal to mg? This is one of the common mistake people do. They take it as mg here. So be careful with that. Step 1, draw the FBD. Step 2, assign the accelerations. I'll help you out a bit. Check it out. Next one you can do. So let the accelerations be alpha. The center of mass is here. How will the center of mass go? It goes in another circle, no? So center of mass is actually going straight down ACOM, which is L alpha by 2. There. Assign acceleration and alpha, find relation between them. Second step. So this is alpha and this is ACOM. Now your FBD is complete. Step 3, apply force equations, the vertical and horizontal direction. Luckily, Nx is 0. Vertically, it is mg plus tension minus ny is equal to ma. And what about the block here? The block is attached here at a distance x. So, iska acceleration kya hoga? X alpha, na? That means this block is actually going with x alpha. This is the acceleration of the block. This is the problem here. If you take t is equal to mg, you are ignoring this acceleration of the block. So block equation will be mg minus tension is m into x alpha. 3 equations. Take torque about the hinge. Ny is 0, nx is 0, mg into L by 2 plus tension into x is equal to I about hinge into alpha. Mg L by 2 plus Tx, and what is I about the hinge? Ml square by 3. That is the reason you need to know moment of inertia values. Please check the equations, FBD and the constraints ones. Step 3 and step 4. Now, all that it is done. Now, we just have to solve, but please check your equations first. Most people goof up this part. They write this as mg and they forget this, and the whole thing goes for a toss. Any doubts on any equation? You're not convinced with any particular step, please ask. Now, what do I want to find? I want to find alpha. So that means I don't want T, I don't want A. So let's eliminate them. Then I just want to get T, right? So here I'll get it from here only. I don't want Ny anyways. So T will be mg minus mx alpha. So if they ask you hinge reaction, that also I can find from here, this equation. This equation is not required right now. Take this guy and dump it in this. Mg L by 2 mg x minus mx square alpha is equal to ml square by 3 alpha. So we get alpha is equal to mg L by 2 plus mg x pi ml square by 3 plus mx square. So yeah, so g into L by 2 plus x by L square by 3 plus x square. That's your alpha as function of x. Please check. Question is not over. Now you need to plot alpha in terms of x. Now this thing goes wrong actually. इतना मेहनत करके इतना किया, this goes actually wrong in a certain condition. Let's see, will you figure it out or not? Think, I'll give you a minute from here. This thing is wrong under a certain condition. What is that? Any doubts on this page? Any step you didn't get, please ask. All clear with this page? Look at this equation here. T is equal to mg minus mx alpha. Now for these equations to be valid, tension should be always greater than or equal to 0. Means x alpha should be always less than or equal to g. Isn't it? Think about it. If you keep the block so far, if this point acceleration goes faster than g, won't the string become loose? If you attach this block too far, let's say you keep this block somewhere here in this corner here, and the moment you cut the string, this point is traveling so fast. This is how the diagram would look. The string becomes slack, isn't it? Isn't that a possibility? If the point of contact, that is the reason I wrote specifically it is a string. If this point cannot go faster than acceleration greater than g, if it goes faster than g, string becomes slack because strings cannot push. If it had been a rod, it wouldn't have been a problem. The question is over here. Because it is a string, the string connecting the block and the rod can't go faster than g. Tension becomes negative. So x alpha, take this alpha guy and substitute there. So x into g L by 2 plus x by L square by 3 plus x square. GG will cancel. XL by 2 plus x square is less than equal to L square by 3 plus x square. X should be less than equal to 2L by 3. So the final answer alpha, I'll run the page. Check it out. So this equation is valid as long as x is less than 2L by 3. If you exceed 2L by 3, the point of connection is going so fast, the string will just become loose. So this guy would be G L by 2 plus x by L square by 3 plus x square. This is right for x less than 2L by 3. And for x between L and 2L by 3, you get a pretty interesting answer actually. If I just substitute x is equal to 2L by 3, I end up with 3g by 12. You get a constant acceleration. Because once you exceed this, if x becomes greater than 2L by 3, string becomes loose. You can just remove the block from the FBT, it is useless. And the block does not affect the rod. Since tension is 0. So if you try to plot this alpha versus x graph, we exactly don't know how the graph looks, but the acceleration alpha will start with 3g by 12. As x increases, it will decrease. It will increase again and become constant. This occurs at 2L by 3. After 2L by 3, alpha becomes constant. Is this clear? So exam question can be framed like this. Find x if the alpha of the rod is independent of x. So once you keep the block more than 2L by 3, it doesn't matter what is the mass of the block or how far you keep the block, it becomes independent. Check it out.
Could you show the previous slide for just a second?
There, this is what I was saying. Everything will come in one go. Calculation of torque, free body diagram, no slipping conditions, acceleration correlation, equation solving.
Yes, so thank you.
Any doubts? Anyone not convinced with this? Please ask. Clear, na, Anika? Utsa, got this? Anusha? Aryan, clear, na? Adit, got it? Next one, can I go ahead? Next one. We have a rod here. This is rough. This is theta. This is mass and length L. Same question. We have a rod here. Mass m length L, but this time the ground is smooth. B is a proper advanced question, right? The string is cut. The string is cut. So in this first question, right? Find alpha, friction, and mu minimum for no slipping just after cutting. This question, no? Finding alpha, this was a J mains question, 18 or 17, I guess. Just find alpha, that was a mains question. Just after cutting. This question, find alpha and a center of mass just after cutting. Let's get them. If I just find alpha, this was a mains question. If you ask to find friction, this is a mains ka tough question. Advanced ka easy one, but the B part is a proper advanced question. That will be advanced, moderate, or even little higher level. Try. Let's get the first A part. Remember the steps. Draw an FBD, draw the forces. Second thing, define your alpha, define your A, find relation between them. Force equations, horizontal, vertical, torque equation, solve. Let me give you any problem. This is the process. Considering, this thing is there's no slipping. Second case, it is slipping. You can't do anything. Friction ground is smooth, no? Case one, it is not slipping. Let's do the first part. Hope everyone has given the test. Today night is the deadline. Check it out. And there are 2 tests also online today and tomorrow night. Sorry. Some people are shocked. And there are 2 papers, rotation and optics also are online. So those who want to give additional papers, you can give them. They'll be there till month end. They'll not be graded though. I'll be putting few more extra practice papers, for this upcoming major test. So that would help. You should have got alpha by now. 3 sin theta नहीं रहा इधर sin theta नहीं आएगा चेक करो goofed up somewhere g cos theta नहीं dimensions match ही नहीं हो रहे god Aryan you forgot theta only Anika your dimensions are not matching I didn't ask you I asked you alpha Ali yeah Ali you got that right get the friction back yeah that is right try everyone got an answer do type in the chat box you should type your answers now it's not well today you look tired sick no you should eat some ice cream isn't that what you do when you have fever you eat ice cream and you become better right? Okay I thought so Aryan that is wrong Anika wrong Lakshika is that cos theta in the numerator or denominator denominator then it is wrong Abhinav you messed up the sign nahi aayega re gods how are you guys getting sign let's see the FBD whether you got that FBD right step 1 FBD normal reaction friction mg that's it any other forces 3 forces and everyone understood why friction is right side If there is no friction, the rod would have become like this, meaning this point is going backward. So friction has to be forward. Next thing, find relation between alpha. Now see, this is the most important point. I'm sure you guys can draw FBDs and all, but generally I notice this is where people find a problem with this acceleration. Let this rod go with alpha. So the center of mass here, this is the hinge, is going in a circle. So your center of mass is not going up or down, it is going at an angle. This is your A center of mass. This is theta. This is theta. So this component will be A sine theta, which is AX. This component will be A cos theta, and this is AY. This is the relation between acceleration of center of mass and alpha. There, you found the accelerations and found the relation between them. So this is alpha, and this is AX, and this is AY. Torque is actually the easiest part. If you just want to find alpha, there's no need to do all this story here. So torque about A will be torque due to N is 0, torque due to F is 0. I'll write it down once for you guys. This is gone, this is gone. This is equal to I about A into alpha. How do you take torque? Extend the vector and drop the perpendicular. This is theta, this is L by 2. So this perpendicular distance will be L by 2 cos theta. Isn't it? So the torque will be mg L by 2 cos theta. Moment of inertia for a rod about the end will be ml square by 3 alpha. You should know your moment of inertia results. So alpha will be 3g by 2l cos theta. Please check. See where you guys goofed up. How are you getting sine theta? 3-4 people got sine theta actually. Aryan, check. I will see where you got sine theta. Anusha, whatever. Friction is mg sine theta. That looks like that. So then you're clear the equations force is equal to mass into AX. AX is nothing but ma sine theta. And A center of mass is how much? A center of mass is L alpha by 2. So ml alpha by 2 sine theta. यहाँ से F आ जाएगा. What is normal reaction? That would be mg minus n is equal to may. So n will be mg minus may. That will be ml alpha by 2 cos theta. There from there you get n also. And we know friction should be less than equal to mu n. So we get mu should be greater than equal to m L by what is L alpha? L alpha, this guy would be 3 mg by 4 sine theta cos theta by n would be mg minus 3 mg by 4 cos square theta. Doesn't look that great, but yeah. So that will be 3 sine theta cos theta by 4 minus 3 cos square theta. That is a mu. Mu should be at least this much for it to not slip. Please check. You have to find F, you have to find N and finish it off. That's why I said this is if the moment I ask you find a mu minimum, it becomes an advanced question. So this is the thing which I'm little worried about. Please ask me if you're confused about this part. That the acceleration of center of mass is at an angle, uska components lena hai, AX and AY. And then you write the force equations. But if you just want alpha, there's no need to do all this story. Just take torque and you're done. You get the answer in one equation. Please check any step you're not convinced, not clear. You're clear with this, go ahead with the second problem. What if the ground is smooth? Find alpha and A center of mass. Problem looks very innocent, like a serial killer. So let's do the B part. Any doubts on the first part, please ask. Anyone not convinced with any particular step? Vidyut, Shastika, Maulika, clear with this thing? Everyone should definitely do these problems on own again today night or tomorrow. So these things look like, but I'm sure, right? Everything feels like, I know this. But until you put it on a paper, it's a different thing only overall. Let's see the second part. What if the ground is smooth? Try, take a minute or two. The problem with the second question, it feels there's not enough data.
Can you show the question for him?
कुछ नहीं रे, ground is smooth, बस वही question था. Do the same question this time, don't put friction. Find acceleration and alpha, and the string is cut if the ground is smooth. FPD, normal, MG, bus. Now what? Think. I'll give you a minute more, then I'll show you. There's a big hint in this FPD. What I draw right now, that's a big hint. Think. Tell me one thing, all the forces are in which direction? Vertical. Are there any horizontal forces?
हाँ सिर्फ वो a sin theta वाला component है.
No. So tell me one thing, if there are no horizontal forces, center of mass will go in which direction?
सीधा नहीं.
Straight down, right? There are no horizontal acceleration. Since there are no horizontal forces, center of mass ka acceleration is in the vertical direction. Since horizontal forces is 0, ACUM goes down. And the acceleration will be vertical. So when you write the accelerations, this guy is going down with ACOM and this guy is rotating with alpha. Now what? 3g 1 minus sine theta by L. That I don't know the answer. But that doesn't look like answer though. Problem here is, now see, this is theta. So this is the acceleration A, and this is alpha. So force equations, mg minus n is equal to ma. Can you take torque about the bottommost point? Yes, no. You can't take. Why? This point is moving now. The point A is moving. You can't take. Then you have to put an apply pseudo force here. This is what I was saying. If you're taking torque, first check whether that is accelerating or not. Torque about center of mass will be, again, extend the vector for n, drop the perpendicular. That will be n into L by 2 cos theta is equal to I center of mass into alpha. We can't take torque about A. We can take, but A is accelerating. A is accelerating, so you have to include pseudo force. Okay. So this guy would be NL by 2 cos theta. This would be ML square by 12 alpha. So N will be ML alpha by 6 cos theta. Equation 1, equation 2, but I have 3 variables. I have A, alpha, N. There is a third equation. We are asking at this instant, na Arya? Aryan. Question is always just after cutting, no? If you give some time to this, will get omega also. It will become more messy. We'll not get into that. Now, where is my third equation? Most people figure out till here. Meaning, the first thing is figuring out this will go down. Just to give an idea, actually, how will the rod go? Initially, the rod, assuming if the rod is vertical, the next moment, the rod will go like this. Then the rod would go like this. And then eventually the rod would be on the ground. So throughout this process, right, the center of mass is always going down. You're getting the center of mass is always traveling down. The rod will go in such a way, it'll always fall down. Conservation of energy. That's an interesting thing. I never heard about it. But how do you find energy, say, alpha and A? That's a surprising thing. So to work for energy with conservation, do you ever find acceleration? Where is my third equation? Anyone? Don't tell me A is equal to R alpha. That's a blunder. Hint is at point A. How is point A going? Left and right. Left, right means it is not going up and down. That means velocity profile. So for this point here, this is going down with A and this is rotating with alpha. So this point A will go down with acceleration and it is also going in a circle like this. So this will be L alpha by 2. This will be your A tangential. Isn't that the velocity profile? Translation plus rotation. So the person on the center will think it is going in a circle and it is also translating itself. This is theta. That would be how much? 90 minus theta. This is theta. So if you look at point A, its acceleration will be L alpha by 2 cos theta, L alpha by 2 sine theta, and the acceleration of the center of mass. Since A cannot lose contact with the ground, vertical acceleration is 0. Because it's neither going up and down. Rigid body constraint. Acceleration along the normal should be same. That means the A center of mass in the vertical component minus L alpha by 2 cos theta is equal to 0. This is your third equation. Is this clear, everyone? The velocity profile. Basically, this rod can be treated as 2 points, isn't it? Plus this. So we are assuming all points are going with A downward. And about the center, every point is going in a circle like this. Isn't that how we find velocity profile? Take translation plus rotation and add them. So the point A is going down due to center of mass, and it is also rotating A tangential because of rotation. The net resultant should be horizontal. This is a good one. This it doesn't strike generally. Keep this in mind. Rigid body constraint, basically, this is. There. Have a look at this. I'll solve it. I'll just solve this here and we'll go back there. So this will be mg minus ml alpha by 6 cos theta is equal to ma. So let's bring this thing here. mg minus ml alpha 6 cos theta is ma. take that L alpha and substitute here. It will be mg minus L alpha will be m by 6 cos theta. L alpha will be 2a by cos theta is equal to ma. M gets cancelled, end up with a is equal to g by 1 by 3 cos square theta plus 1 3g cos square theta by 1 plus 3 cos square theta. Check. That's your acceleration of center of mass. Interesting. Check out the steps. So once you got the equation, it's just a matter of substitution. I hope these two equations are clear, right? Force equation, torque equation. This third one was the main thing. Please check. It's a good one. So the second part, when the ground is smooth, is a interesting one. Next one. Turn the page. Aditya, Arjun, clear? Rehan, got this? Lakshika, clear, na? Avina, go ahead. Perfect. Next one. We have a disk here. Mass m, radius r, rotating with omega naught. The ground is rough. Friction is mu. Imagine dosa. You're getting? It's like, if you can see my screen, if this is the disk, it is rotating like this. You're getting how it is? So the disk is rotating like this. So you took a disk, you're rotating with omega and kept it on the floor, rough floor. Find the time when it stops rotating. A rotating disk is placed on a rough horizontal ground. Find the time when it stops rotating. This is the side view. Let's get this. Anyone didn't get the diagram of the question, please ask. How would we do this? How will the friction be? No, address, that is wrong. How will the friction be? Just to give an idea, if you look at the top view, if this disk is rotating with omega like this, the friction will be like this, circular, isn't it? At different points, you have different frictions. You have to integrate. Now, how do you proceed from here? Try. I'll give you a minute or two. Just to give an idea, you have to take rings. Each ring will have a torque, and then you have to integrate the total torque to get this thing. Nee, Lakshika, you also did the same mistake as Adrita, I guess. Did you guys take like torque is equal to friction into radius? You took it as mu mg into r. So do you mean to say all the friction is acting on the circumference only? See. So I will take a small ring. So on this small ring, the friction will be F, F, like this in a circle. So the mass of this ring dm will be total mass by total area of the disk into the area of this ring, 2 pi x dx. So take a ring at a distance x and thickness dx. So the friction, now be careful, this is not exactly friction, this is the tangential friction on the ring. What's the total friction on the ring? If someone asks you, find the frictional force on the disk, what will you say? Anyone? 0. Because see na, for every one friction here, there's one friction here. They cancel out. They all form couples. Total frictional force is 0, but torque is not 0. So be careful with that. Friction is not there only. Total friction is 0. Friction is there, but they're all getting cancelled out. This is the frictional force on the ring. So torque on the ring will be x into friction tangential again. That's why I'm writing tangential. Don't write friction on the ring. That will be 0. So this guy would be 2mx dx by r square 2 mu mg x square dx by r square. That's the torque on the ring. The torque on the disk will be add all the torques on the ring. So there'll be, every ring has a different mass and different torque because x is different. So this would be 2 mu mg by r square integral x square dx from 0 to r. That would be 2 mu mg r by 3. So torque on the disk is equal to I alpha 2 mu mg r by 3 for a disk moment of inertia is mr square by 2. That's the reason you should know moment of inertia values. Or else after doing this much, you will goof up here. 4 mu g by 3r. Since alpha is constant, I can use omega final is omega initial plus alpha t, circular motion. Omega final is 0, omega naught, and alpha will be minus because it's in the opposite direction. 3r into time. So time will be 3r omega naught by 4 mu g. Check. Please check the steps. Because the reason why you're getting friction is because of the weight, and each ring will exert different amount of normal reaction. So you get different friction, and each ring is at a different distance. You get a different torque. So you have to add all the torques due to the ring to get a disk, because disk is a rigid body. All the rings are connected to each other, so you can't take each ring separately. And if you look at here, the outermost ring has the highest torque. Check it out. Friction on the ring. So the question you need to ask is this. Is the disk, what is the velocity of the disk, Utsa?
What's it?
What is the velocity of the disk? See now, what is the velocity of the disk? Don't get confused.
Velocity.
Velocity is 0 hai. Angular velocity omega naught hai.
Yeah, that's what I was.
Nah, I know you're getting confused. So velocity is 0 hai na?
Huh.
So you don't need a friction to stop. You want to stop omega, so you want torque. Don't get confused. You want to stop omegas, you need torques. You want to stop translation, you need forces.
Acha, okay.
Isn't it? Omega has nothing to do with force. It looks like they're related, but nothing related. यहाँ पे friction का force is 0, but friction का torque 0 नहीं है. And that disk is anyway not translating, so it doesn't matter.
Okay, okay.
Disk is rotating, so you need a torque. Clear with that? Yeah, that's a general confusion people get, so be careful with that. All clear with this? Now, this question, we can extend this into something else. We can change the same problem into a different level, say. Meaning, if this similar question, if you want to ask in a little easier way, but still advanced one, this is how it will be. We have a square plate. On a rough horizontal ground. This is the top view. Huh? This is hinged in the center. And this guy is given omega naught. So this takes time t1 to stop. Now, calculating the time t1 is a pain. You can't calculate it. Ring जैसा इसका कुछ symmetry नहीं है. If you take elements, it will be pretty messed up here. But the question will be like the same disk. Instead of that, if you hinge it here, same mass, same surface, everything is same. And now you give omega naught. Time taken to stop is t2. Is that making sense? Depending on where you're hinging, time will stop. Find t1 by t2. They'll ask you a question like this. Calculating t1 and t2 is very difficult, but ratio you can manage. Now, this will be a good question where you don't solve much, but you have to think of it. Let's get this. Ask me if you're confused. You took a disk square plate and hinged at the center and you gave omega naught. It will take t1 to stop. The same disk, same surface, but this time you hinge at the corner and rotate. It takes time t2 to stop. To find t1 by t2. How do we proceed with this? 1 by 4. Not exactly. 1 by 4 nahi hai. Any other answers? By root 2, nahi. See, these kind of questions, right? What you want is always the proportionality. You don't want exact values anyway, since you're asking ratio. So when you hinge it in the center, look at this thing. The torque. Now, the torque dimensions will be whatever is the torque thing. Dimension should be same. So torque is proportional to mu mg. Agreed? Whatever is the torque, that will be proportional to mu mg. Fair enough. And this also should be proportional to I alpha. So I'll do one thing. If I write this thing as torque is equal to some constant K into mu mg L. If you observe here also you got something similar. Dekho. We got torque is equal to 2 by 3 R. So here torque will be proportional to where M is the mass and L is the side. Because torque ka dimensions to match hona chahiye na. You will get some constant here. I don't know what is this. K is some constant. And we know this is proportional to I is proportional to alpha. So K mu mg L, and this I also know moment of inertia is ml square by 6 alpha. So mm will cancel, L will cancel. You end up with 6k mu g by L. So alpha is proportional to 1 by L. Means you take any square plate, the angular acceleration is proportional to 1 by L. And we know omega final is equal to omega initial plus alpha t. Eventually you're stopping to 0. This is omega naught minus alpha t. So alpha is proportional to 1 by t. And we also know alpha is proportional to 1 by L. Therefore, the time is proportional to the length of the side. Getting the proportionality? Now both are not same, but see what we can do. This plate, when you're hinging in the center, can I do like this? I can just make 3 more plates like this. I'll make m by 4, L. I'll make this m by 4. So the same plate I will split into 4 plates. Now you have created a big square of side 2L with the center as the hinge. Is this making sense? Now you need to understand, I derived this result under the assumption the hinge is in the center. I can't use this for this guy when it is in the corner. But if I can open the plate into 3 more pieces, I will get a big square plate. Fair enough? So therefore, T1 by T2 will be L by 2L, which is 1:2 ratio. Means if you take a square plate of side L and side 2L, and if you hinge in the center and give omega naught, the time taken is proportional to the length. Torque is proportional to length. Moment of inertia is proportional to L square. So you get alpha proportional to 1 by L. Higher the alpha, lesser the time. So alpha is inversely proportional to 1 by time. Please check. There, no need to use any integrations and all that stuff. So this is the main idea there, symmetries. So they want to ask you a question where they don't want you to integrate, but thoda sochna hai, this would be a proper advanced question. Now using this idea, I can give you any other shape also. Square is special. Like I keep saying, square is always special. Clear with this? Have a look at this. Take a break. Come back by 7:5. Take it, make it 7:7. Any doubt so far? Anything that you can get at previous page here? Previous page is just a question, right? I hope you're getting that idea of, opening the plate into 3 more and making it a bigger square plate. That's the idea there. Someone is saying something.
Sir, in this question, we divide the mass also to m by 4. Right?
No, it is the same plate. I made it into bigger. See, tell me one thing. By taking this plate here, this distance, if I keep it here or here or here, did the perpendicular distance change?
No.
So torque won't change. So moment of inertia won't change. Nothing will change, right? But by making like this, doesn't this look like this now, but a bigger version? Then I can compare now. I will say both are same except the length is different. But can you, by seeing this, can you see this and say like both are identical? नहीं है ना? You will say like, sir, ये तो corner में है, ये तो center में है. How will they be identical? But once I make it a bigger version, you will say, both are same. Only the difference is side is 12.
Okay.
And we know that logic, right? As long as you keep the mass same at a same distance, it doesn't matter how you keep it.
Okay. Yeah.
So I just made this plate of mass m. उसको मैंने और 3 plate में छोड़ दिया. So it became total mass is still m only, right? So there.
Yes, sir.
Sure. Others, anything? ठीक है. Take a break. Come back by 7:07. Aryan, clear so far? Abhinav, clear na?
Yes, sir.
Chalo, take a break. I'll be back in 5 minutes.
So we have a rough pulley here. Mass and radius are. You can treat it like a disc. Chalo, cams on everyone. Gravity is there. Find the acceleration of the block.
What is the difference between a rough pulley and a smooth pulley?
Friction लगेगा.
Friction लगेगा. So till now, see, I'll just give you the difference here. Listen, everyone. So till now, whatever we did till work power energy, right, was all smooth pulleys. So when you take a smooth pulley, the difference is this. Listen carefully, idea is important. So in a smooth pulley, you know what happened? The pulley never rotated actually. For example, see, if you look at my screen, right, it is like this. The thread which is there is always, it is just sliding over it. The pulley never rotated. But if the pulley had some friction, this is how the motion would be. Meaning this whole system would rotate. You're getting? In real life, the pulley which you see actually rotates. But till now, what we did, we have taken the cylinder to be smooth, the pulley to be smooth. This pulley never rotated actually. The string was simply sliding over it because there was no friction. So whenever you do a problem, this is the thing you have to be careful here. So if you have a smooth pulley, M1, M2, and if you take the string here, so if you take this side tension T, this side also tension will be T. So that is the first thing. The tension is same on both the sides because there is no friction. And the second thing, cylinder never rotates, pulley never rotates. But if you have a rough pulley, the difference is the tension will be different on both the sides, T1 and T2. Reason, this is T1, there is a friction on the string now. That's why the tension will be different. Just keep that in mind. That's the main important thing. Whenever they say pulley is rough, that you can't take tension same on both the sides. Due to friction, tension varies. And in this case, pulley rotates. So till now in work power energy, we have never considered pulley ka rotation. The pulley never rotated. It was always smooth. It was simply sliding. Now, how do you know when you see a question that you have to use rotation or NLM? Which words in this question will give you out that thing?
Rough mass.
Mass and radius.
I never gave you the details of this thing for a pulley before. Mass to फिर भी दिया होगा, radius I never gave. And this is the second most important one, no slipping. No slipping indicates the pulley is actually going with the rope. It is not slipping. So how do you do this thing? Take a minute. I'll show you.
What shape do we consider a pulley or cylinder layer?
We generally take it as a disc only or a cylinder.
Okay.
Right, Yasha, Lakshika, both of you got it. See, FBD. This tension T dash, your own weight mg, tension T, block M, tension T and mg. Now here, see, there is a page again here, this one. Now see, accelerations, right? This is alpha, this is A. Now don't blindly write A is equal to R alpha. Are you getting it? That's a blunder. Reason, this is how you should get it actually. I'll tell you why that is important. Because of alpha, this point is going with R alpha, which is A tangential. This point is A block. Since the string is touching the pulley, there's no slipping condition. So A block is A tangential. A is not equal to R alpha because of circular motion. We get A is equal to R alpha. Then you're done. So take torque about the center. T into R is equal to mr square by 2 alpha. T is equal to ma by 2. Mg minus T is equal to ma. We get A is equal to 2G by 3. Check. This one. Next page, this one. Check. All clear with this? Let me show you a faster way to solve this problem. Or let me show you, I'm saying no, this constant why it is important. Let me show you a variation of that. Just write the equations, you will understand what I'm saying. That same question, let's say you're in an elevator. Inside the elevator, there is the cylinder with this block. Let's say this is M and this is also M and R. You can treat it like a disk and no slipping. And this elevator itself is going up with A naught. Now write the equations for this, the ground frame. Now they'll ask you find tension in the string. Find the tension in the string connecting the block. Get me the equations. Gravity is there. The whole accelerator is going up though.
So can you go to the previous page a bit?
How Udyan? Any answers? Focus, focus.
Thank you.
Okay. Get me this. Now you'll understand why that constant is important. If you blindly write A is equal to R alpha, you'll get trapped. And when you write A is equal to R alpha, where are you getting that from? That is not from circular motion. A is equal to R alpha. See, if I write the equations now, let that be T dash, T, own weight mg, block M, this is T, this is mg, let this be alpha, let this be A. Now look at this no slipping condition. Huh? This pulley is going with A naught and this is rotating with alpha. So this point has an acceleration R alpha minus A naught. And this is connected to a block which is going with A. So here the no slipping condition is acceleration of the block will be R alpha minus A naught. This is the catch. If you directly let A is equal to R alpha, it will be gone now here. If someone asks you what is no slipping condition, it means at the point where the string is touching the pulley, the string and the pulley should have same acceleration. Isn't that the no slipping condition? A is equal to R alpha is not the no slipping condition. Keep that in mind. Then equations are same though. So if you take torque about the center, T into R is equal to I alpha, mg minus T is equal to ma. They all look same, only the constant equation will be different. I will leave it to you here. This equation will change. Everything else will remain same. Substitute and you'll get the answer.
Pseudo force will be applied on the block, right?
मैं ground frame में ले लिया directly. We are doing everything in the ground frame. If you do it in this lift ka frame, na, then the question will look like previous one only. But then the answer you get also will be with respect to the lift. Na. Again, you have to add the lift ka acceleration there. Meaning, use pseudo force if you stand here. Right? हाँ, so I kept my observer on the ground. तो pseudo force नहीं लगेगा. Please check. Clear? You can solve and check the answer. I don't know this thing. Now, how to solve this question? You know, this previous one little faster. There's a shortcut. We can write alpha is equal to net torque by total moment of inertia. If you remember, we have done something like this in loss of motion, net force method. Net force along the string by total mass. Well, the only problem with this thing is it's valid only for single pulley. If you have one pulley and even 1,000 blocks, you can still use this. But if you have two pulleys, this is gone. So how do we use this? Step one. Treat the blocks like particles. I'll show you an example. And attach them at the point where the string meets the pulley. Step two. Find torque about the hinge and I about the system. I of the system. Now look at our example here. So this is what we do. So wherever the block is connected, so this is where it is connected. Now assume all this mass is located here at M. What are the forces? mg, pulley ka own weight, mg. So torque about the hinge will be mg into r. Moment of inertia of the system will be I of the pulley plus I of that particle now. That would be mr square by 2 plus mr square. So what is alpha? Torque by I. mgr by 3 by 2 mr square. That would be 2g by 3r. Since it is not slipping here, we can see that string ka A will be R alpha here. That would be 2g by 3. Since the pulley is not accelerating directly. Same thing. This will be more useful, when you have multiple blocks. I'll show you. This problem is still fine, but if you have 2-3 blocks, right, you have to write a lot of equations and solve. This will save our time. Do check out this thing once, how to do. The thingy part? What is thingy part? Hinge part. Torque about the hinge, na? If you take torque about the hinge, this mg is passing through, na? So this torque won't be there. Only this torque will come mg ka. Block ka torque. Right? Clear, everyone? So using this, let's see, how can you frame questions?
Can you show previous page?
Let's say we have M1, we have M2. This is mass and radius R. You can treat it like a disk. No slipping. Theta 1, theta 2. We have a pulley here, MR, no slipping. M1, M2. The ground is smooth. Wedge is fixed. You can have a pulley with multiple layers. This is M2. This is M1. I is the moment of inertia of the pulley. This radius is R2 and this radius is R1. So this tension is T1. This tension is T1. This tension is T1. Find alpha and T1. All the three cases. Find acceleration alpha of the pulley and tension T1 in the string. Using that shortcut which I taught you, you can get these things faster. Remember the steps. Wherever the string is connecting the pulley, attach the mass there. Write the torque about the center, take moment of inertia, finish off, you'll get alpha from there. One equation. Extra is finding the tension in the string. It doesn't matter. You can choose M1 or M2, whichever is greater. First one, you goofed up. I think you're getting the signs wrong. यहाँ पे ना all are not in the same direction. You have to be careful here. See the first one. So the pulley is there. It has the mass here, M1, G. It has the mass here, M2, G. Assume alpha is this way. Now look at this thing. If you take torque about the hinge, M1G ka torque is supporting, right? M2G ka torque is opposing, no? Both the torques are not supporting alpha. So you can choose alpha any direction you want. So torque grid will be M1GR minus M2GR. And moment of inertia of the system will be pulley is mr square by 2 plus M1 R square plus M2 R square. So alpha will be M1 minus M2 G by MR by 2 plus M1R plus M2R. And how to get the tension? This would be M1G and this would be acceleration. So M1G minus tension T1 is equal to M1A. So from here you get T1 directly. M1G minus M1R alpha. Sure. So here basically, if you see both the torques are on opposite, M1G and M2G are cancelling out. And how do you know which one is greater? Doesn't matter. Choose anyone is greater. The signs will take care of it. If M1 is greater than M2, my assumption is right. If M2 is greater than M1, I'll get a negative sign. I gave M1, M2, so the M's won't cancel, so be careful. What about the next one? Keep going, I'll give another 1 minute for each. So once you got acceleration, you have to draw an FBD for each block to find tension. There's no way out. If I ask you tension in the string, draw the FBD of that block. Second one, what we do, pulley here. Now see the mass when you attach here, this would be M1G sine theta 1. This would be M2G sine theta cos theta 1. Passing through center. This will be M2G sine theta 2. Basically, the cos components will be 0. And you also have your own weight mg. So if you hear talk about the hinge, again I'll assume this is alpha. This would be M1G sine theta 1 minus M2G sine theta 2 into R. Moment of inertia will be same thing, R square by 2. Moment of inertia doesn't care about angles and all, it just see the distances, M2 R square. Alpha will be torque by I. So for this block here, if you write the force equations, this is M1G sine theta 1. And this is acceleration. So M1G sine theta 1 minus tension T1 is equal to M1A is equal to R alpha. Solve this, you'll get tension T1 from here. Check it out. Are you clear what I'm doing here? You got the steps, right? So you can just replace that entire thing and finish it off. If you try to do this normally, you have to write one equation for this, one equation for this, pulley ka one equation. That will be 3 equations and one no slipping condition. 4 equations you have to solve. Saves you time, nothing much. Third one. As long as you keep the pulley same, alpha is same, you can use this. If you have multiple pulleys, this is gone. We will see one problem if you have multiple pulleys. M1G R1 minus M2G R2. The I of the system will be I of the pulley plus M1 R1 square. Here the distances are also different. M2 R2 square. So from there you get alpha. Interestingly, if you see the accelerations, right? If this is A1 and this is A2, A2 will be R2 alpha 2. R2 alpha, A1 will be R1 alpha. Accelerations are not same. And mg minus T1 is M1 into R1 alpha. From there you get T1 also. Check. If they ask you tension in the string, you have to draw the bit of the block. This will give you alphas. From there you can figure out the accelerations.
Sir,
Yeah,
can we write I of pulley as MR1 square?
we don't know, no? We don't know what is the shape of the pulley, how it is looking. Pulley agar aisa hai, to what will you do? It's like something like this, no? I don't know the exact shape. So they have to give me some information. Then you have to tell me either the pulley is made of 2 discs. Then I can calculate. Got it? It can't be a single disc. So I don't know what it is. So I have to give you ICA value. Please check. Clear with this method? Quite useful. When there's a single pulley, saves you time. Let's see if it's not a single pulley, what to do then. Then you don't have an option. You have to try FBDs and solve it generally. Any doubts on this page? Turn in the page. Swastika, Monica, clear, no? Ali, got this? Anika, Arjun, Neil.
Yes.
Next one. Let's say we have a big pulley here. We have a small pulley here, and we have a block here. So this pulley is M comma R. This pulley is 2M comma 2R. You can treat them like discs only for a solid cylinder. There's no slipping anywhere. So the string is going like this. Find acceleration of the block. So there are 2 pulleys, 1 block, so 3 equations and 2 constant equations. How do we do this? Just give me a minute. Let's see whether you got the FBD right. 2G by 7. Okay, now I don't know the answer actually. 2G by 5. Okay, we have two different answers. See whether you got the FBDs and the equations right. So first thing for this block, tension T1. I hope you took the tensions different because the pulleys are rough. And for this pulley, tension T1, tension T2. That is a thing. If you have taken the same tension, you're gone. Whenever there's a rough pulley, tension will be different on both the sides. And for this big pulley, I'll just take this tension T2 there. Next thing, let this be alpha 1, let this be alpha 2. दोनों का same alpha नहीं होगा. Radius is not same, mass is not same. And this is acceleration. Then, if you look at the no slipping condition, they're connected like this. That means this point ka acceleration will be 2r alpha 2. This point ka acceleration is r alpha 1. And this point ka acceleration is a. So a should be equal to r alpha 1. This should be equal to 2r alpha 2. That is your no slipping condition. The entire string will have same acceleration. So if you write the equations, mg minus t1 is equal to ma. And if you take torque about the first pulley, I'll write it as torque for the small one. That would be T1 R minus T2 R is equal to I. I will be mr square by 2 alpha 1. And torque for the big guy would be T2 into radius is 2R. Moment of inertia is mr square by 2, but m is 2m. R is 2R by 2 into alpha 2. Check your equations. If you got these equations, you're done. Now it is just a matter of solving. That's a pain. That you will see. So here what I want is A, right? So that means I don't want T1, T2. I don't want alpha 1, alpha 2. Great. So let me simplify. So this T2 guy will be 2R will cancel, 1, 2 will cancel. This will be 2mr alpha 2. And I know 2r alpha 2 is nothing but MA. Perfect. This is T2. And T1 will be mg minus MA. Dump it here and dump it here in both the second equations. So R will cancel. You end up with mg minus ma, and T2 is minus ma. This guy would be m by 2, and R alpha 1 is ma by 2. That would be 1 plus 1. A will be 2g by 5. Not bad calculation, actually. Meaning, when you get a lot of equations, you need to understand what you don't want. Keep this in mind. It is always more easy for us to figure out what you don't want. Did I goof up somewhere here? Check my calculations. If I goofed up, let me know. So the main idea here is, since I want A, it is clear I don't want T1, T2. So eliminate T1, T2. Did I mess up somewhere? I wrote 2R alpha 2 as A. 1 plus 1 plus R looks fine. Lakshika, did I mess up or you messed up? Check it out. because two people got 2g by 7. Even you got, Swastika also got 2g by 7. Aryan and I got 2g by 5. You took same alpha for both. Okay. If you have taken, we also did the same, Swastika, you took same alpha. This is the problem here. If the alpha is not same, you can't use that net torque method. Check it out. Clear, everyone? Can I go ahead? Next one. Aryan, clear, na? Yasha, got this? Neil, Palaksh, clear with this? Rehan, got it? Vartika? Next one. We have a solid sphere. Mass m, radius r. The ground is rough. There is no slipping. So this is the center. Someone is applying a force F at a height h. Find acceleration of center of mass. Friction. Frictional force on the solid sphere. Get this. So someone is applying a force F at a height h and they're pushing it. Find the acceleration of center of mass and the friction on the ground. F by m, near God. I'm sure you forgot friction on the ground, na? Delta said not slipping. FBD people, I'm sure you forgot the FBD. That's it. Force F, friction, normal reaction, mg. These are the forces. Acceleration of center of mass and alpha. Now, if you try to solve this normally, right, these are the equations. F minus F is ma. Torque about center of mass is equal to F into h. This distance is h. Plus friction into r is equal to I center of mass alpha. No slipping condition. At the bottommost point, you have a minus r alpha. This is touching the ground. The reason why I keep writing this every time now is important. Every time it will not be equal to r alpha. So a minus r alpha is 0, and therefore a is equal to r alpha. I have seen most people goofing it up, without realizing it. Now, this is one way. I don't like this. There is a much better way to do this thing. If you look at here, this point A is special. What is the acceleration of A? Acceleration of the ground, isn't it? And what is the acceleration of the ground? 0. Therefore, A is inertial frame. Luckily here A is not accelerating. So I can take torque about A. Got it? I'm not taking A, A ka advantage A hai, 3 forces are passing through, see. But you have to be sure that A is an inertial frame. So torque about A will be F into H plus R is equal to moment of inertia about A into alpha. The F into H plus R moment of inertia about A will be 2 by 5 mr square parallax theorem plus mr square alpha. So we end up with alpha is equal to 5F by 7 mr square H plus R. And A is equal to R alpha. 5F by 7mh plus R. You want to find friction, uske liye option nahi hai. F minus F is equal to ma. So we get friction is equal to F minus ma. So substitute that. F minus 5F by 7h plus R. There's one more R missing somewhere. There's one more R sitting here. So this guy would be 2F by 7 minus 5FH by 7R. That would be 2R minus 5H by 7R. That's your friction. Check. So taking torque over the bottommost point will save you a lot of time. You get it in one step. Clear with this? There is something good about that friction if you observe here. If you look at the values here, friction which we got, F by 7R, 2R minus 5H. If you make this friction is equal to 0, we get H is equal to 2R by 5. Means if you apply the force at HR by 2R by 5, there will be no friction on the body. This would be a good question. Where should the force be applied so that the body will never slip? Even if the ground is smooth, this will roll. So remember, they'll ask a question like this: can a body roll on a smooth surface? People think no. Again, don't get confused. Rolling matlab at the bottommost point, the relative velocity should be 0. Suppose if H is greater than 2R by 5, then friction becomes negative. Then the friction will be backward. If H is greater than 2R by 5, friction will be forward. Because I took F backward in the FBD. Friction is forward. If H is less than 2R by 5, then friction is backward. So you can play around like this also. Friction ka direction will changes depending on what height you are. Here I assumed F is backward, right? So F should be forward here. The simple logic, the higher you go, you are producing more alpha than acceleration. So the bottommost point is going backward. The friction will try to oppose that. So in this case, right, the body sphere can roll even on a smooth surface. You don't need any friction to roll. Previous page here.
फिर तो वो F minus F equal to MI से वो calculation wrong हुआ ना?
I wrote wrong here.
Friction forward होगा ना?
Where? No, I took F backward and I got this, na?
अच्छा, you don't know H not right.
मुझे पता है ना F का direction I don't know, तो I assumed any direction I want and the sign will take care of.
Okay.
All clear with this? Great. Next one, few homework problems. Try them and come in the next class. Definitely try these things because these things will take time. So spend some time on them. So we have a table here. So there is one block here, 2M. There is one more pulley here, and this is M. The strings are perpendicular. This rod is M, mass M and length L. You're getting how is the diagram here? Gravity is there. And these pulleys are smooth pulleys. So these pulleys are not rotating. A rod is placed on a smooth horizontal table. With blocks M and 2M attached to the ends. And acceleration of center of mass and alpha of the rod. Clear? This is one. Have a look at this question. You can try this later on. Question is understood? So this tape block, this thing. So the diagram would look like this. Top view, na? Initially it is like this. After some time, this guy is going to become like this, right? So this thing is rotating and translating. Because masses are different on both the sides, the rod will start rotating also. This is one. We have a solid cylinder here. Mass and radius r. And someone is pulling this with force F. Basically, this string, right, is the cylinder is rolling over it. The ground is smooth. And here there's no slipping between the cylinder and this thing. I mean, that is rough. There's no slipping between the cylinder and the plank. Find acceleration of the plank, acceleration of the cylinder, alpha of the cylinder. Second part, find the kinetic energy of the system after time t. Assuming the cylinder does not fall off the plank. Able to visualize how is the question? clear with this? Then we have a square plate. Mass M, side L. We have two strings. We have two springs. These are strings. These are springs. So you're cutting here, you're cutting here, you're cutting here. Find the alpha of the square plate just after cutting at point A. To make sure to try these three problems. So we have a rod here on a table there, and two blocks are connected M and to M. Cylinder on a plank, and it is connected through a string. Third one, three square plates. We have a hinge, we have a string, and we have a spring. 40th is a good question. Like, this is a question where it will, tell you like what's the difference between a hinge, a string, and a spring. So how each one behaves, that is a good thing about this question. And this one is a good one because this is a proper advanced question. Especially the second part is interesting, and the constraint part is fun in this. This is still fine. It's kind of a rotating and translating thing. So definitely everyone should try these three problems before next class. Next class, when we meet, first thing we are going to discuss these three problems. So spend some time because each question will take at least 7 to 10 minutes. So I wanted to try properly and come for the next class. So do try them. Okay, with that we'll wrap up for the day. So there is a test online till Thursday night, so make sure to give. And then okay, we'll catch up on Friday again. So we have 2 days in the middle. So any doubts, anything, you can stay back, or else you're free to. So take care, stay safe. I'll see you on Friday at 5:30.